Welcome, everybody. My name is Andrea. I have the pleasure of working for the Fleet Science Center as the Adult Programs Manager. And tonight we're here for our Sky to Night talk. It's a monthly talk the Fleet hosts, normally at the Fleet Science Center, but COVID makes it a little bit difficult, so we took the show online. And we're really glad that we have the opportunity to do that. This way we can keep you connected to the things you love. I'm hoping to welcome many of you back. So welcome back if you've been here before. Welcome if you have never been here before. We're really glad to see you. And just a little bit about tonight. I'm not sure if everybody saw the beginning presentation. We're going to start off our presentation with Dr. Lisa Will, who is the Fleet's resident astronomer. She's going to give a presentation, and then afterwards we have time for Q&A. And during the Q&A, I'm going to try something new. I have prepared a poll because I want to learn a little bit about you and what you thought of the program. So we created a little poll. So during the Q&A, I will throw that up there and you can hopefully take a minute to fill this out. Just 9 short questions. Shouldn't be too big of an ask, I hope. And also quick, we are really excited that the Fleet Science Center is reopening on July 3rd. So that's coming up pretty quick. We're not quite sure when we can bring the Sky Tonight show back into the live space, but we'll keep you posted on that. Until we can, we will be here virtually for you, I promise. We will not let you down. The stars and we are here for you. All right, with that, Lisa, I'll throw it over to you. Take it away.
All right, thank you so much. Let me share my screen here. Let's try that again. Sorry, sometimes it's not quite seeing there we go, let's try that. Sometimes it takes a moment to see PowerPoint. There we go. All right. So, hi, as Andrea said, I'm Dr. Lisa Will, and I'm a professor of physics and astronomy at San Diego City College, as well as the resident astronomer at the Fleet Science Center. And I'm so happy that we have been able to bring the Sky Tonight to you during this time. So let me tell you a little bit about the Sky Tonight. The Sky Tonight is a planetarium show typically that we do the first Wednesday night of every month. And then we specialize to a different topic every month after we do a sky tour. So we're going to do a sky tour and show you what the sky looks like tonight. I'm going to talk about some current events, and then we're going to talk about Mars. We focus on a different topic every month, and since July is normally Comic-Con, we always do a nerd topic every July. And so even though we can't go to Comic-Con in person this year, we're going to celebrate Comic-Con at home here at the Fleet and talk about Mars and popular culture, or Mars fact and fiction, after we do a sky tour and talk about some current events. So I want to start off with something that's going to happen on July 4th, which is the Sun and Earth is going to be at their maximum distance from each other. So we achieved something called aphelion on July 4th. And so what I'm showing you here on the screen, these are 2 images of the sun taken with the same camera on the same telescope. So they're to scale with each other. So the fact that the sun looks larger on the left-hand side, January 4th, and smaller on the right-hand side, July 4th, means that the Earth was actually further away when this picture was taken. So every year around July 4th, we are at our farthest distance from the sun, and every year around January 4th, we're closest to the sun. Just a reminder to you that distance isn't the reason for the seasons, but it's the axial tilt of the Earth that is the reason for the seasons. So right now, the northern hemisphere is experiencing summer because the tilt of the Earth has the northern hemisphere of the Earth towards the sun. And the southern hemisphere is experiencing winter right now because the southern hemisphere is tilted away. What you're seeing here, you'll notice these are 2 images. At the bottom it says New Horizons, and then Earth as they flip back and forth. The New Horizons spacecraft, you might remember, passed by Pluto in 2015, and it passed by Arrokoth on January 1st of 2019, and it's keeping going. And these are pictures that it took in April of this year. On the left-hand side, we're looking at Proxima Centauri, which is the closest star to the Earth. On the right-hand side, we're looking at Wolf 359, which some of you might remember from Star Trek, where the Borg attacked. That's an actual star, and it's one of the closest stars to the Earth. And the New Horizons spacecraft is the first spacecraft to send pictures of the difference in where those stars look up against the background of stars between the spacecraft and the Earth. This is something called parallax. If you look at your finger with one eye open and then with the other eye open, you'll notice that your finger appeared to move even though it didn't. It was your point of view moved, and that's what we're seeing here. So the New Horizons spacecraft is the first of our exploratory spacecraft to send back parallax images of some nearby stars. And then another thing I wanted to show you, an amateur astronomer named Clyde Foster was taking pictures of Jupiter recently, and he noticed something that's labeled on this image as Clyde's spot. And what was interesting is that astronomers who had been looking at Jupiter just a few hours earlier didn't see this spot. And so what is this? Well, NASA's Juno spacecraft is currently in orbit around Jupiter, and its track took it fairly close to where this was. And so if we take a look at Jupiter, see that little white peanut looking cloud shaped thing near the great red spot, and we do call that the great red spot. That actually is a new, what they're referring to as an outbreak. You might notice in this beautiful image of the cloud tops of Jupiter, you're seeing all sorts of swirls and ovals and white ovals and brown ovals, because astronomers call them white ovals and brown ovals. We see all these storm type features in the atmosphere of Jupiter, and some of them are very long lived, like the great red spot that you see there that we've seen for hundreds of years, literally at this point. And some of them appear and then disappear, like a Clyde spot here in this image. And so I wanted to show you that, and also to let you know amateur astronomers can actually see stuff from the ground that's really amazing. And then if it picks up a lot of attention from astronomers, professional astronomers will do follow-up observations to see if it's something interesting and new. And so this is something called, we're thinking it's a region where some of the cloud tops are kind of bursting through. It's kind of like a convective cell we see in our own atmosphere. And so that's just some current astronomy events going on right now. Let's start off our tour of the nighttime sky.
Lisa, there's one quick question in between,
Okay.
if you don't mind. What is Juno? I saw it on the diagram.
Okay, so Juno is one of NASA's spacecraft. It is currently in orbit around Jupiter. And what's really interesting, well, there's many interesting things about it. Due to its orbit, it gets really close to Jupiter on some of its passes. And so it takes these really amazing images. And the images are put up on the Juno spacecraft website for people like you and I to play with, because that camera is purely there for citizen science, for us to play with, because all of the other objectives of the Juno spacecraft, which is gravitational mapping of Jupiter, trying to figure out the size of its core, the magnitude of its magnetic field, all of those things didn't need a camera. But there is a camera built by Malin Space Science Systems from here in San Diego County that is on there taking beautiful images. So yeah, Juno is a current NASA mission. All right, so what I did was I set the planetarium software for what the sky would look like at 9:30 tonight. So south is at the bottom of the screen, north is at the top of the screen, east is to your left, west is to your right. And so the point directly overhead, if you were to go outside, is pretty much right in the center of your screen. So this is what it would look like at 9:30 tonight. So let's do a little bit of a sky tour, starting off with a constellation that a lot of people are familiar with, which is Ursa Major, or the Big Bear, which you are mostly used to seeing as the Big Dipper. So this part here, let me see if I can try to spotlight it a little. There we go. So this part right here, oops, not there, up there, up there, up there. There we go. All right, so that part, getting used to that part there is the Big Dipper. That's what you're used to seeing up in the sky, but it's actually part of a larger constellation called Ursa Major, or the Big Bear, which is one of the larger constellations up in the nighttime sky, taking up a significant percentage of the sky up in the northern part of the sky. So if you were to try to go outside and look for this tonight, you would want to look behind you. Now, when we take a look at the Big Dipper, we can use this part here, the arc or the handle of the Big Dipper, and we say we arc to Arcturus, which is the brightest star in the constellation Boötes. Boötes refers to a herdsman, and the star Arcturus, its name comes from a term that means guardian of the bear, likely because it's up in the nighttime sky near Ursa Major and Ursa Minor, which is a little bit harder to see the way I have this listed up there. Now, Arcturus is one of the brighter stars that you've been noticing if you've been looking up at the sky in late spring and early summer so far. And it is a star that's located about 37 light years away from our solar system. And so a light year is the distance that light travels in a year. And so when you take a look at Arcturus up in the sky, you're not seeing it as it is, but rather as it was about 37 years ago. And so that's in one way that space can be kind of like a time machine, because we can see it in the back, as we can look back in time. And so if we continue on using the handle, we say we arc to Arcturus, and then we speed on to Spica, which is the brightest star in the constellation Virgo. Now, Virgo is a constellation whose name you might be familiar with from being a sign of the zodiac. So the first thing I want to mention about the zodiac tonight is that the signs of the zodiac gained in cultural importance because of their location on the sky, because they fall along what we call the ecliptic. And so the line up on the sky now, the ecliptic, is the ecliptic, which marks the path of the sun on the sky. So what you're seeing there with the months of the year being laid out is where the sun would be on any given day of the year. And so because we are July 1st, that's kind of hard to believe for me right now, but because it is July 1st for us, and I have this set for 9:30 tonight, the sun would be below the western horizon. And so that's why July is below the western horizon. And so the sun moves through these constellations, and that's how they gained importance. But not just the sun moves through these constellations, but the moon and the planets do as well. So if you were to go outside tonight and want to know where the ecliptic is, you're going to look for some bright dots, one of them being the moon, which is up there in the sky tonight, and the other one being the planet Jupiter, which will be rising over in the southeast at around 9:30 tonight. So now that we've determined what the zodiac is and where the zodiac signs got their importance, let's go from west to east across the sky, looking at the signs of the zodiac, starting with the one that is over along the western horizon, and that will be setting at around 9:30 tonight, and that's Leo, which is depicted as a lion up in the sky. Leo is actually a pretty bright constellation. You can see it even from a city like San Diego, as long as the clouds are cooperating. What you do is you look for that backwards question mark in the front of it. That marks the head in the front of the lion. We call that the sickle. The star at the bottom of the sickle is the brightest star in Leo. That's the star Regulus, and it's located about 77 light years from our solar system. And then you can also find that triangle in the back that marks the tail of the lion. And the bright star at the edge of, or at the very tip of it, is called the nebula, which is shortened from a phrase that means the tail of the lion. And it's located almost 40 light years from our solar system. And so if the marine layer cooperates for us tonight, you should go try and take a look for Leo as it's setting along the western horizon. The next sign of the zodiac then over to the east is Virgo, the maiden. It's the second largest of the 88 constellations that professional astronomers use today. And the brightest star Spica is usually depicted, when you see the mythological character of Virgo, she's usually depicted as holding an ear or sheaf of wheat, and that's where the term Spica comes from. Spica is the 15th brightest star in the sky as seen from the Earth, and it's located about 260 light years from our solar system. And Spica is a star that is easily visible from San Diego. So that's one way that you can try to find where Virgo would be on the sky tonight, because remember, you can arc to Arcturus and then speed on to Spica, making this big arc in the sky. The next sign of the zodiac over to the east is Libra. Libra is a harder constellation to find. In fact, if you want to look for where Libra is up in the sky tonight, look for the moon. That's going to be the easiest way for you to find it this evening. Libra it basically represents scales of balance or scales of justice. It is the only sign of the zodiac that does not represent a living creature. And it is fairly bright. It's really hard constellation to see from a bright metropolitan area like San Diego. Its brightest star is Zubin el-Ganubi, whose name comes from an Arabic term that means the southern claw. Now, the scales of justice don't have a claw, but the next sign of the zodiac over to the east does, which is Scorpius, the scorpion. And I like pointing that out because the constellations and their boundaries have changed over time. So the fact that there is a star that's historically called the Southern Claw, and it's now in Libra, tells you historically at one point it used to be in Scorpius. Now that doesn't mean it's moved, but it's just that astronomers use constellations as ways to give positions on the sky, and the boundaries of where a constellation begins or ends has changed over time. Our definition of those boundaries has. So let's go look at Scorpius, which is probably my favorite sign of the zodiac because it kind of looks like a scorpion up in the sky. If you want to look for it here in San Diego, you do have to look to the south. So you're not going to be looking up like this. You're going to be looking lower on, like down towards the horizon. And the brightest star in it, Antares, is that bright red dot that you see here. And it is something called a red supergiant. It is a huge star. Its radius is over 800 times the radius of the sun. So if you were to put Antares in our solar system where our sun is, Mercury, Venus, Earth, and Mars would be inside of it. In fact, its outer layers would actually be in between the orbits of Mars and Jupiter. So it's absolutely huge. And its name, Antares, means opposer of Mars, because Ares is the Greek god of war, and Mars was the Roman god of war. And so Antares, opposer of Mars, is because Mars is another red dot that gets really close on that part of the sky, because Mars, the planets follow the ecliptic. And so we'll take a look at Mars bright and red up in the sky a little bit later. The next sign of the zodiac over to the east is, I keep going the other way because I keep wanting to point east, so I keep hitting the east arrow. So that's my problem there. So it's Ophiuchus is the next sign of the zodiac. And some of you are probably going, Dr. Well, I've never heard of Ophiuchus. Ophiuchus is not something that I see. Well, Ophiuchus is the 13th sign of the zodiac because the sun passes through Ophiuchus at the beginning of December. And so it does fall along the ecliptic. Ophiuchus represents the serpent bearer, which makes a little bit more sense if you actually put the constellation Serpens, the snake, up with him. So he is holding a snake up in the sky, Serpens Code and Serpens Kaput. Its brightest star, Rasalhague, comes from a term that means the head of a serpent collector. It's about 50 light years from our solar system. And it's overall kind of faint to be seen with the naked eye. So when you go outside tonight and you want to look for Ophiuchus, find the moon, find Antares, and take a look to the east, and you'll be looking in the direction of Ophiuchus. And then the next sign of the zodiac over to the east is Sagittarius. So Sagittarius will be rising in the southeast at around 9:30 tonight. And Sagittarius represents an archer. But one of the things you might notice is we often refer to this part as the teapot. You have the handle here, and you have the spout. And so we see what we call the teapot asterism in Sagittarius. And where this is pointing is towards the center of our galaxy. So when you notice that there's this band of light going across the sky in this image, and that is the Milky Way. The Milky Way is the name that we give to the galaxy that our solar system is in. The Milky Way galaxy is estimated to be about 100,000 light years across, and we are about 27,000 light years out from the galactic center. And so you might notice that down where Sagittarius is, the Milky Way looks sort of widest and brightest. And that's because we're looking towards the center of our galaxy in that direction. As we travel through our galaxy is flat like a pancake, and we're seeing the pancake of the galaxy going across the sky. In fact, if we follow that pancake of the galaxy, that band of light going up to the north, the next sign of the next constellation I want to mention, now that we're getting away from the ecliptic, is Aquila, the eagle. This is thought to represent the bird or the eagle that carried Zeus's thunderbolts in Greco-Roman mythology. Its brightest star, Altair, is one of the brightest stars that we can see in the sky and one of the closest stars that you can see with the naked eye. Now, that might surprise you that closest and brightest aren't necessarily the same thing, but all stars aren't the same wattage, so to speak. Not all stars are the same brightness. So a lot of the stars closest to our solar system are actually really faint and you can't see them with the naked eye. So this is one of the closer ones that you can see with the naked eye at about 17 light years away. And as we continue north, we come across the constellation Cygnus the Swan. Sometimes people refer to it as the Northern Cross. It just kind of depends on which orientation you're looking at it as. The brightest star in Cygnus is the star Deneb, which is one of the farthest stars that you can see with the naked eye at about 3,200 light years away. And so I think that those are a great example of how it's really hard to estimate distances on the sky. We do not have good distance judgment on the sky. And then there's a third bright star up in that part of the sky, the star Vega, up in the constellation Lyra. Lyra represents the harp of Orpheus from Greek mythology, and its brightest star, its name is a reference to an eagle, actually, Vega is. And so we have Altair the eagle, we have Cygnus the swan, and we even have another star up here named after a bird. So we have sort of a mythological tie-in up there. Vega is the fifth brightest star that you can see in the Earth's nighttime sky, and it's about 25 light years away, and then we estimate it to be about halfway through its lifetime. And these bright stars, Vega and Lyra, Deneb and Cygnus, and Altair and Aquila, make up a constellation that we call the Summer Triangle. This trio of stars makes a huge triangle up in the nighttime sky, and you will see it throughout the summer and well into fall if you go outside and look up for it. Let's talk about a few more constellations of interest before I get all geeky and nerdy about Mars with you. We have Hercules up here, a mythological hero from Greco-Roman mythology. The brightest star in it is named Kornephoros, which comes from a Greek term that means club bearer, because Hercules is usually depicted as holding a club over his head. This is the fifth largest constellation that astronomers use. Professional astronomers have agreed upon 88 constellations that we all use. We agree upon their names and their boundaries, and this is the fifth largest one. And Hercules is up near Draco the dragon, probably inspired by the dragon Ladon, who Hercules encountered during his 12 labors in Greco-Roman mythology. The most famous star in the constellation Draco is the star Thuban, which used to be our North Star several thousand years ago, because the Earth makes three motions. It rotates on its axis, it revolves around the sun, and its tilt wobbles like that of a top. And so over the course of 26,000 years, we make one wobble, which means over the period of thousands of years, the North Star changes. And so Thuban was the star closest to being marking true north, I guess I should say, about 3,000 to 4,000 years ago over time. And so those are the constellations I wanted to point out to you tonight. And then I wanted to just point out again that the moon and Jupiter will be up tonight. So the moon's going to be easy for you to find because it's, the moon, it's in waxing gibbous phase, so it's nice and big and bright out there this evening. Jupiter will be the really bright dot rising in the east later tonight. And so I wanted to show you a couple images of the moon and Jupiter that maybe you haven't seen yet. So let's take a look at the moon. All right, this is a real image. Isn't that amazing? So you might notice we're looking back at the Earth from the vantage point of the moon. This is an image from the Lunar Reconnaissance Orbiter, and it actually took this about 5 years ago, but I just don't think enough people have seen it and appreciated it. Our moon is much smaller than the Earth. It's about 1/4 the radius of the Earth. It's about 1/80th the mass of the Earth. It only has 1/6 the gravity of the Earth. And that 1/6 the gravity of the Earth means it can't really hold on to an atmosphere. And so it was never able to maintain liquid water at the surface. And so you just see this amazing stark contrast between what having an atmosphere can allow you to have at this distance from the sun and what not having an atmosphere causes. So beautiful, beautiful contrast. So I thought you might like to see this image because it's a view of the moon and the Earth that you might not have seen before. And then picture of Jupiter for you. Once again, from NASA's Juno spacecraft. I can't make that annotation go away, so we'll just move it over there. So what I wanted to show you this one because, like I said, the Juno spacecraft, its image data is from, it's put out onto the web, onto the Juno spacecraft website in downloadable form. You can even play with it in something. You don't need special software. You can play with it in Photoshop or anything like that. And this is a image that was rendered by David Marriott, a citizen scientist who put this together at a time when Juno was only about 40,000 miles above the surface, which, you know, sounds like that. I mean, that sounds like it's so far away, but Jupiter's huge, right? So that's about as close as it's really close to Jupiter. And I can't get over how beautiful Jupiter is, all of the swirls and clouds, and you really get a feel that this is, you see fluid dynamics. You're probably looking at this thinking, this is what it looks like when I pour cream into my coffee. And that is what you're seeing there, fluid mixing, and the different colors there correspond to clouds of different chemical compositions and actually different heights. Just like the clouds in our Earth's atmosphere get higher and lower, we actually see that happening on Jupiter as well. And so that's a tour of tonight's sky and some of the objects visible in tonight's sky around 9:30 tonight. Now, if you were to go out later, around 1 o'clock tonight, or 1 o'clock this morning, you might notice a bright red dot rising in the eastern sky. And that bright red dot's going to be Mars. So I wanted to show you Mars. So this is an image taken several years ago. That's one of my favorite ones to show why people may have referred to Mars as the god of war. In fact, so the planet Mars is named after the Roman god of war. In Babylonian astronomy, the name that they gave to Mars was named after their deity of fire and war and destruction. And that's because Mars can be very bright and blood red up in the sky. And this is taken several years ago when it was up in the near the constellation Taurus. And so you can see it contrasting with the bright blue stars of the Pleiades, that little cluster of stars off to its left. So due to its bright and reddish appearance, Mars has long been of interest to humanity. So what do we know about it? Well, let's take a look at this animation first. We have Mercury, Venus, Earth, and Mars to scale with each other. And now let's let them rotate. And now they are rotating to scale with each other. And you'll notice that Mars is significantly smaller than the Earth. It's only about half the radius of the Earth, but it's tilted and rotates very similarly. Yet we're all a whole lot smaller than the Jovian planets. And then the sun just makes us all look real tiny. But so just to take a look at this again, this time you'll notice Mars and the Earth rotated about the same rate and at the same tilt, and that Mars is only about half the size of the Earth, so its gravity is weaker. It only has a gravity of about 1/3 the gravity of the Earth, and it's able to hold on to much less of an atmosphere. So when we take a look at Mars, you're going to see an atmosphere, but not much of one. Mars has 2 moons. And these 2 images show Mars' 2 moons eclipsing the sun from the point of view of the Mars Curiosity rover. Both of these pictures were taken this spring, and they were processed by Kevin Gill, who posted them on Twitter. So the one on the right shows Mars' tiny moon Deimos eclipsing its sun, and the one on the left shows its larger moon Phobos eclipsing its sun. And you'll notice looking at them that they're not round. You know, they're not perfectly round like our moon is. They are smaller, irregularly shaped, and a different chemical composition than Mars, and they are likely captured asteroids. So Mars is smaller than the Earth, has 2 moons. It has the largest volcano of the solar system. This is an image of Olympus Mons, or Mount Olympus, the home of the gods. And it is a shield volcano, like the Hawaiian Islands here are on Earth, where they build up in height by successive eruption, laying down lava and cooling and getting larger and higher and higher. If you could take this volcano and put it on the southwestern United States, it would cover up the entire state of New Mexico. It's absolutely huge. So Mars has the largest volcano. It also has the largest canyon in the solar system. This is Valles Marineris, or Mariner Valley, and we have the United States superimposed over it. So you can see one end of this canyon would be in California, the other end would be all the way onto the East Coast. Unlike our own Grand Canyon, though, this is not a feature that was carved out by water. We think this is something called a tectonic fracture. Those round things over on the left, those are actually big volcanoes too. And this whole region over there on the left is called the Tharsis Bulge, which is uplifted with respect to the rest of the surface of Mars. So this could actually be a crack, an actual opening, a fissure in the crust of the planet Mars that is affiliated with whatever uplifted the Tharsis Bulge, which is just really sort of fascinating. So this is not a canyon carved by water, but we do see evidence for water on Mars. You'll notice that whitish stuff in here is ice. Mars has ice caps. They're made of a combination of water ice and carbon dioxide ice. And I love these images because we have had enough spacecraft in orbit around Mars taking pictures that we actually caught an avalanche in the process here. So Mars, we've been watching long enough that we've seen changes on, and that's really one of these amazing things to me. So we do see water in the form of ice. There is evidence for seasonal water flow on Mars. In this case, we actually think it might be water leached from the water vapor in the atmosphere and kind of condensing out. Those gray streaks that you see in this image are not always there, and they do seem to be seasonal, where because Mars does have seasons, because it is tilted similarly to the Earth, so it has seasons for the same reason. And we do tend to see these sorts of grayish, or I should say streaks, and geological features when it's warming up in these regions. So we think it has to do, we see seasonal flow of water on Mars. Very weird stuff. These are images of Mars from the Mars Global Surveyor spacecraft, which is no longer in operation, but was an incredibly successful spacecraft. And so you'll notice the ice cap. You'll see the southern cap in this case. That means it was summer in the northern hemisphere and winter in the southern hemisphere, because Mars ice caps actually do have some seasonal variations. They get bigger in the winter and smaller in the summer. And you'll notice this right here is Olympus Mons, that really, really big volcano. And these are 3 other volcanoes there. You can see them because they got that whitish color on them. Those are clouds that are forming over the calderas, or over the summits of these volcanoes. So Mars does have an atmosphere, but because you can see the surface so clearly, you know it doesn't have a very thick atmosphere. And then this is the other hemisphere of Mars, that large kind of lighter color circle down towards the southern cap is something called Hellas Basin. It's one of the largest impact basins in the solar system. Because Mars does have an atmosphere, we get to see Martian weather. Mars can actually have really big dust storms, which is why the rover Opportunity doesn't work anymore, because Opportunity's solar panels got covered up by dust in a dust storm and was no longer able to draw solar power. So we kind of lost it, which makes me still unhappy and sad to this day. But we do see dust devils forming on Mars. And this is a picture of a dust devil going up a crater wall. And you'll notice the black streak that it left behind. Well, in color, these streaks can look like this. So this is one of my favorite images of Mars, because you see so much going on. You see sand dunes, windblown sand dunes, and then some geological form sand dunes. You see these trails left behind by dust devils. You see those long streaks that could be that water flow. Again, just all sorts of stuff going on here. And I remember the first time I showed this image in an Astro 101 class, I had a student ask me if it was a tattoo, because that's kind of what it looks like. But no, this is an image of the surface of Mars taken from a spacecraft. Speaking of spacecraft, we still have some spacecraft working on the surface of Mars. We've got the Curiosity rover still going around here taking a selfie so that we can see what it looks like. And the InSight lander is still working, and there's still several spacecraft in orbit around Mars taking images. So we still have a lot going on there. And this was one of the first images that the Curiosity rover sent back. And I still really love it because they picked Gale Crater for the Curiosity rover to land in because it had evidence of perhaps having water at some point in that region. And then you see these sedimentary layers in the hills of the crater wall, in which as Curiosity has been roving around this large crater, we've seen a lot of evidence for water there. And because Mars does have an atmosphere, we see sunrises and sunsets. And so this is an image that the rover Spirit took back in 2005, and it's still one of my favorite images. This is sunset on Mars. And you get this sort of bluish color at sunset due to the fact that the Martian atmosphere, there's really, really, really tiny sand particles in it, and the way they scatter the blue light immediately around the sun that you can only really see when looking directly at it. And we never look directly at the sun, right? I do not condone that, but the time at which we're most likely to glance that way is near sunrise and sunset. So that's what we're seeing here. How many times can I say possibly my favorite image of Mars? This image of Mars shows high cirrus clouds up in the sky, and we're seeing sand dunes. Oh, this is a picture from the Opportunity rover, and where Opportunity landed, we purposely put it in a very wide, flat space. And I just love this image because it tells you so much about Mars. It tells you that it has an atmosphere, that you have sand dunes, you have these patterns that are typically related to wind or geological erosion of some other form, and it just looks familiar. And so Curiosity is a little bit taller than Spirit and Oppie were, but they all have these cameras that are around where human eye level is, about anywhere from 5 to 7 feet off the ground, depending on which rover we're talking about. And so when we see these images of Mars, we feel like we're standing there. And that's because they're actually taken from about that height. And there's something about Mars for that reason that seems so Earth-like. And in many ways, Mars is the most Earth-like planet in the solar system, and especially of the terrestrial planets, even though it's much smaller than we are. And then this image, you might be wondering, what are we even looking at? You're looking at Martian soil through so when Opportunity had the ability to scoop up dirt and do soil analysis, and all the rovers have had the chance to do that. And what you're looking at here is about an inch square of Martian soil. And so you're seeing individual sand grains on Mars here. So that's the closest thing that I'm going to show you of Mars tonight. It's one of the closest up images that I can actually show you of anything here. So because Mars captured our imagination early on, we've tried to learn a lot about it. So we've sent all sorts of spacecraft there. And sometimes those spacecraft have even looked back at us. This is an image from the Mars Global Surveyor spacecraft turning back and looking towards the Earth and the Moon. And so this is what we would look like from Mars. So our curiosity about Mars has driven us to learn about it, but it's also driven us to imagine it. And that's where Mars in fiction comes in. So where do some of our ideas about Mars come from? Well, back in the mid-1800s, Schiaparelli did this sketch of Mars. And basically he was laying out what he was looking at. When you take a look at Mars through a small telescope, you can see basically darker regions and lighter regions. And that's what he was sketching out here. Now, you might notice some of the lines that he'd drawn. He called them canali, which means channels, and a channel can be a geological feature, but they were mistranslated into English as canals. So when you think of channel, you think of something that is a natural feature. When you think canal, you think of something people built. And so that actually affected how people started thinking about Mars. So Percival Lowell, who built Lowell Observatory up in Flagstaff, Arizona, when he sketched Mars, he made those lines really linear. Like, this looks like something somebody built. That's a very different thing than a natural channel. And I remember once being up at Lowell Observatory taking the tour, and I asked the docent, so when Lowell was doing this in the early 1900s, we had photography. Astronomers were already using photography. Why wasn't he taking pictures of Mars? Why was he drawing them? And apparently Lowell did not trust this new photography technology. So he still was doing hand drawings, but when he was biased with what he expected to see, he expected to see these sort of features on Mars that were linear. And so he drew them as lines. So if you have these linear features that you might call canals that make them sound like they were made, then you get the idea of like, well, maybe there's a civilization on Mars. And so then that's where the fun begins. And then you get like War of the Worlds stuff going on. So H.G. Wells wrote War of the Worlds back in the late 1800s. And this is actually an image from one of the early French editions of it with the tripods, the Martian aliens walking around the Earth. And so we have been associating Mars and aliens for over 100 years, and that sort of infected how Mars is perceived in popular culture. I had to show Marvin the Martian, and this is a still from the very first debut of Marvin the Martian back in 1948. And so with the Earth in the background, you'll notice the Earth doesn't have clouds, just like old Star Trek, the original series before they redid all the graphics. You never see the Earth with clouds. And then more recently, we have Martians depicted. This is Martian Manhunter, or John Jones from DC Comics. And so, who is a shapeshifter, and we also have Ms. Martian and stuff like that from the same group. And so Mars and aliens have shown up a lot together. Another fun connection between Mars and comics is this graphic from the Watchmen graphic novel, where in the Watchmen graphic novel, the smiley face was a key motif in it. And so what was really interesting was that around the time that Alan Moore and Dave Gibbons were working on this, where Dave Gibbons was the artist, well, he saw the happy face crater on Mars. There is actually a happy face crater on Mars. And so when Gibbons noted the similarity, he said it was almost too good to be true. I worried if that we put it in, no one would believe it. But there is a happy face crater on Mars, just in case you were worried that something in Watchmen wasn't real. So this is not the only face on Mars. Some of you might remember this image. This image taken from the Viking 1 orbiter back in 1976 of the Cydonia region of Mars has this feature here that kind of looks like a face, and everyone got excited over it. And a lot of people say perhaps that this is something that was made by a civilization. This part of Mars has shown up in lots of popular culture at this point. I decided I was looking for something to show you, and this comes from the Mission to Mars movie, where it became an artifact that featured prominently in there. But I'm sorry, it's just a mesa. Right, so this is a picture of it from the Mars Reconnaissance Orbiter. This is the Viking orbiter. It's just a coincidence. The angle of sunlight coming in that day and the lower resolution, it made it look like a face, but it's really just a hill. Sorry, that's not quite as interesting, I know. Other popular depictions of Mars. We have the book The Martian by Andy Weir and the movie The Martian. This book and movie got a lot of the science right. The movie in particular was really great about how Mars looked. The only problem with the science was actually the big dramatic part at the beginning where the wind was blowing everything over. There's wind on Mars, but the Martian atmosphere is really, 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 really thin. So it wouldn't be knocking things over like that. But once we get past that point, it was pretty good, actually. That didn't make me angry. And then some more recent depictions of Mars in popular culture. The Expanse features Mars as a lunar or as an Earth colony that is now independent. And so we see Mars in that show prominently, show in books prominently. And then Mars has always been featured in Star Trek. That was Mars is the site of the Utopia Planitia shipyards, where our favorite starships are built. And then more recently in Star Trek Picard, we see it featured as a location. And we see it here with Picard in a dream sequence. And so Mars has really captured our imagination. And because of that, we have gone to explore it and trying to learn about it. And Emily Lakdawala at the Planetary Society very recently posted this, where I love how she titled this graphic, "Every Mars landing attempt ever, successes, failures, and future." And it kind of gives you an idea of what's been done on Mars, what's ongoing, and what's still to come. So that's just a quick tour of the sky tonight and Mars, both fact and fiction. And now let's go ahead and take some questions. But first I'll ask Andrea, do you want me to stop sharing the screen or?
Yeah, that would be good. I think well, keep it up. I don't know if you want to maybe reference one of the slides. Might be helpful. I'm not sure. So I'll leave that up to you.
You just let me know.
As always, we have little time and many questions, which is great. I love the more questions, the better. Is Ursa Major, so we're going back, some of the questions were from the Sky Tonight portion. Is Ursa Major visible from the southern hemisphere?
No, it's not. It is so close to what we call the northern celestial pole that, I mean, if you were along the equator, yes, because all constellations hypothetically are visible along the equator, but the further south you go, the less likely it is to be visible based on your latitude. So it would be visible in very few locations, enough for me to say like, not easily visible from the southern hemisphere.
Since we're talking about hemispheres, is there a south star like Polaris in the north?
So that's a really great question. There is a south celestial pole, which would be the point directly above the south geographic pole of the Earth. But if you were standing at the south geographic pole and pointing straight up, there would be no bright star there. So there actually is not currently a south star, which made navigation a little bit more complicated than having a steady beacon of light pointing north in the sky. I believe, though, what you can do is use Crookes, the Southern Cross, kind of to point towards where the south celestial pole would be, but no bright star there.
Too bad.
You know.
What is the difference between an asterism and a constellation?
It's a great question. So an asterism is made up of stars that are not necessarily all in the same constellation. So for example, the Summer Triangle that had 3 stars from different constellations, but it's big and prominent enough for you to say, hey, look at that triangle up in the sky. That's an asterism. Similarly for the Big Dipper is basically the bright stars of Ursa Major that you've noticed over your life, but it's part of a much larger constellation. So you can think of them as subsets of agreed upon constellations.
Which brings us to the next question, which is how are constellations named?
Ooh, that's a really good one. And a lot of these are really ancient names. So back in the 2nd century, an astronomer named Ptolemy cataloged 48 constellations in the northern hemisphere, and astronomers started using them to reference points on the sky. And we actually still use a lot of those till this very day. And then when you got into the southern hemisphere, which was documented later by northern hemisphere explorers, we have a very northern hemisphere bias when we talk about these naming conventions. So you see names like telescopium and microscopium, which means that they were cataloged later by basically northern Western European catalogers in this case. And then over time, astronomers just basically said, and there is a group called the International Astronomical Union that actually now makes things sort of official. And astronomers have agreed upon 88 constellations that the professional astronomers all use. But obviously, constellations have been in use for thousands of years amongst many different cultures. And we've kind of, professional astronomy has kind of picked pieces of all of those in its naming conventions on the sky.
Thank you for that. Are there stars outside the Milky Way that can be seen with the naked eye in the sky?
I'm going to give you a yes and a no there. No, in terms of individual stars. Yes, if you're talking about stars as part of a galaxy. So there is the Andromeda galaxy, which is visible in the northern hemisphere to the naked eye in the fall, if you know exactly where to look for it. But individual stars outside the Milky Way visible to the naked eye, nope, sorry.
Not without superpowers, anyway.
Not without superpowers. Not without superpowers, or a really good spaceship.
Could the volcano that we saw earlier in one of your pictures erupt and do some damage to the solar system?
Probably not. The only thing that we would be curious about is whether or not it had, if the explosion was enough to kick up material with greater than the escape velocity of Mars, which means that the material would go up and not fall back down. And we do know that sometimes that happens because not necessarily due to volcanism, but we have Martian meteorites here on the Earth. In fact, I'm wearing, my necklace has a little bit of dust in it from a Martian meteorite. It's a little vial of Martian meteorite dust because I'm a nerd and I had to do something like that to tie in with Mars tonight. But in terms of doing us damage, no. Perhaps giving us a sample of Mars to play with, we can only hope.
Now I want that necklace. Thanks very much, Lisa. How tall are the sand dunes on Mars?
Oh, that's a good question. It varies because I mean, I'm gonna like not give you a specific numerical answer and just say it varies just the way it does on Earth, depending on wind, soil size, soil composition, and the angle of the wind and so on. And in some cases, the sand dunes, like near the poles, are actually ground down by the ice receding and retracting and so on during the seasons there. So there's a lot of variations, and some of them are higher than others. Sorry, I can't give you an actual number there, but the geological processes that form the dunes would be the same as they are on Earth. So think of the factors here on Earth, and that would help you figure that out there.
And you just mentioned the ice. We have a question here if the water could either return or reappear on Mars.
So the water on Mars is interesting because we think that Mars in its past had a lot more liquid water on its surface. And so to do that, though, it would have needed a thicker atmosphere. And we think Mars has lost a lot of its atmosphere through two processes. In one case, Mars doesn't actually have a magnetic, or does not have as strong a magnetic field as we do, so some of its atmosphere can be lost by interaction with the solar wind. But also, and it doesn't have as strong a gravitational field to hold on to an atmosphere like the Earth does. But also, Mars appears to be undergoing something that we call the reverse greenhouse effect. So the greenhouse effect on Earth is what keeps us a nice, comfortable temperature currently. We don't want the greenhouse effect to get out of control, something called the runaway greenhouse effect, because then we end up heating up and all of our ice would turn into water, and then the water turns into vapor eventually, and all that vapor goes up into the atmosphere. And then you end up being a really nasty place like the planet Venus, which is not a nice place. Mars, and that's because Venus was too hot for liquid water to be stable on the surface. Mars, at its distance from the sun, was too cold to be for liquid water to be stable on the surface, and also cold enough that the water vapor in its atmosphere would precipitate out faster than it would evaporate back up. So if you think of the water cycle here on Earth, right now the water cycle on Earth is roughly in balance. We get, water evaporates up into the atmosphere, and then it rains or snows back out. When that water cycle gets out of balance is when you have the problem. And that's kind of why we care about the amount of greenhouse gases in our atmosphere. On Mars, the greenhouse effect, we can explain its atmosphere by the greenhouse effect in reverse. And so it's like the atmosphere has settled on to the soil. And so to get liquid water stable for long periods of time on Mars, that's where you get into the science fiction again of maybe terraforming Mars and making a thicker atmosphere, which would be really difficult to do and usually involves really bad science in movies that talk about it, right? But that's why people talk about terraforming Mars, to make it more Earth-like, to have a thicker atmosphere so that water could be stable.
Somehow it didn't want to unmute me, but here I am. And before we go to the next question, I did promise at the beginning I'm going to throw up a little poll to get some sense of our audience, and I don't want to forget, so I'm going to throw that up, and so that'll just take a second. There we go. The poll is now in process, so if you all could take a second to fill this out while we continue to answer questions. We can do multitasking. We're good like that.
Sure.
So Lisa, next question. Will future rovers have a way to clean off their own solar panels?
So that's a really great question. You're imagining sort of like windshield wipers, something like that. They should. What's really interesting is that Spirit and Opportunity weren't supposed to last as long as they did. They initially had 90-day missions, if I recall correctly, and we figured they were going to last beyond that. But the reason why their batteries lasted as long as they did was because the solar panels remained clean longer than we thought. And the cleaner was accidental, but you know those dust devils? There's, I think it was Opportunity that actually took pictures of dust devils basically coming across it, and then suddenly the amount of sunlight on the solar panels went up. And so we actually do think the wind on Mars might not be able to be enough to blow over a rocket or something like that, but enough to actually clean the dust off of these solar panels, which is why after Opportunity solar panels got covered, astronomers kept listening for OPI for so long, because we were really hoping that the wind would actually clear it up enough so that OPI could sort of live again. But yeah, I don't know what the feasibility is. Like, you know, solar panels are usually pretty delicate, like by whatever mechanism are you dusting with it? Are you damaging the panel? Like, what is the cost benefit analysis there? But I am all about keeping these missions going longer. So, and I'm betting somewhere at NASA, someone's still listening for OPI from time to time. I'm betting it's happening. Yeah.
Yeah, I would think that's true. But it also leads nicely into the next question. Somebody heard that land is available for sale for $30 per acre on Mars. Have you heard that? Is that true?
No, as far as I know, nobody owns Mars, and so you can't sell it. There is an outer space treaty yeah. Because I mean, if that was real, I am going and buying some right now. But I don't think anybody can own Mars currently legally. So save your money there.
Good call. And do you know why Martians are depicted in the color of green all the time?
I don't know. I don't know if the phrase little green men comes before or after the depiction, but I'm going to have to look that up now. But I really don't know.
I'm sure if somebody can find the answer, it's you.
Well, not all Martians are depicted like in DC Comics. There's the green Martians like John Jones, but then there's also the white Martians and so on. So we actually do see Martians of different colorations depicted, but I don't know why green is always the prominent one. I'll have to look.
Do you know how cold Mars is?
Mars is colder than the Earth. So think of Antarctica and think colder. So the average temperature on Mars is less than the average temperature on Antarctica. Without having a number off the top of my head, that's where I would think that way about it. Now, when Mars has a dust storm, it can actually increase the temperature because the dust storms make the atmosphere thicker. And so unlike here on Earth, where we have a lot of particulates, we actually go through a period of cooling. Believe it or not, we have enough pollution in our atmosphere that there is a global cooling mechanism that has occurred. It just doesn't win over global warming by a long shot. But when you have these particles in the atmosphere on Mars, because its atmosphere is so thin overall, the addition of these dust particles actually allows it to retain more heat. And so we have seen temperature variations due to the dust storms, but still think really cold. Think colder than you have probably ever been as the average, is the high temperature.
And then has Mars any other moons, and which of the current moons came first?
So
And that comes from Grant, he's age 11. Hey Grant, thanks for joining us tonight.
Hi. Thanks for asking. So as far as we know right now, Mars only has two moons, Phobos and Deimos. And they're tiny and they're captured asteroids, most likely captured asteroids. So it's hard to know which one got captured first then. But we do know that Mars could have had more moons in the past, and therefore it could gain more in the future if due to this capture process. But yeah, right now we only know two. In terms of which one was discovered first, that was Phobos because it's bigger, so it was easier for us to see. But both of them are small. Like instead of thinking the size of our moon or the size of the United States, think of the sizes of cities or smaller. That they're small objects.
And then with all the pandemic delays, and that comes from Peter. Hey, Peter. With all the pandemic delays, are NASA's Perseverance and China's Tianwen-1 rovers still scheduled to launch this month?
You know what? I don't know. I haven't heard specifically of any delays. I know people have been working at home, still working on these. But yeah, I haven't seen anything specifically saying that they have been delayed, but I will take a look at that now. I will definitely yeah. And I mean, I would think since Perseverance would have been launching so soon, it would be in the news right now, and I haven't really heard about it. So I'm thinking it must be delayed.
Yeah, probably.
I'll give you an update next month.
Perfect. So Peter, you better be back next month. And for everybody else, we know Peter. He's a regular. So, Bill is asking, could the Martian helicopter hover over the lost rovers and clean off their solar panels? Oh.
So could we make sort of a helicopter to do that? It's kind of hard to do with such a thin atmosphere. So you might remember that the way the Curiosity rover landed with its 7 minutes of terror, or whatever it was that they called it, because Curiosity was so heavy, a parachute wasn't going to be enough to slow it down because the atmosphere isn't thick enough for the parachute to have worked that well. So they actually ejected the parachute and then did the sky crane thing, which actually had thrusters or little rockets on it. So I don't know that we could get some sort of quadcopter or drone going on Mars. Now, the next interesting spacecraft mission that will have sort of a helicopter type vibe going for it is the Dragonfly mission to Saturn's largest moon, Titan. Because Titan actually has a thicker atmosphere than the Earth does. So what's going to happen there? This is a really exciting mission, and it just got its grant funding last summer, so it's not anywhere near until being launched. But what's going to happen with it is it's a rover that's going to land, and then it's got like a helicopter part, and it's going to fly somewhere else on Titan, and then it's going to do more research. So it's like a rover that flies. It's really awesome. I can't wait for this one.
That sounds amazing. Yeah.
But the atmospheric pressure on Mars is less than 1% that of the Earth. So being able to use something to fly around Mars would be really hard to do.
Yeah, that makes sense. And it's perfect timing. That was the last question. We had a nice comment from one of our attendees thanking us for this wonderful and interesting presentation. And that thanks goes to you, Lisa.
Thank you for attending, all of you.
And I'm going to show us I'm going to end the poll, and I think that will show us the results, I think. This is the first time I'm doing this, so it's a science experiment. Stay with me. So yes, I can share the results. Look at that.
Yay.
Yeah, look at that. So people liked the event. They thought it was good to excellent. Thank you so much. And people only knew a little. Most of them only knew a little about the subject beforehand. And people learned a moderate or a lot today from you, Lisa. I appreciate that very much.
That is good to know.
They found most of you guys found that very interesting. Thank you. And We have folks who have not attended the Sky tonight before, so welcome.
You're welcome.
We hope you enjoyed it and will join us again. Please also make sure, if you're close to the fleet, to come join us when we bring the show back to the Heikoff Dome Theater, when it is safe to do so for everybody. People will recommend it to their friends, and we've got lots of people from San Diego County. We've got some from other parts in California, out of state and out of country. Oh, welcome from wherever you're joining us. This is great. And then we have a little bit age breakdown. So thank you so much for answering those short questions. It helps us to learn a little bit more about you and make sure that we're giving presentations that are of interest to you and that are received well. I really appreciate it. Oh, we have somebody from Australia. Yay! And oh yeah, we have a question, how many people we have. We had at a high time tonight 82 people joining us tonight for this talk, so this is amazing.
Thank you. Thank you so much for showing up. We really appreciate it, because we miss you guys. We miss being in the dome with you guys, but at least we can do this.
And if there are some out there who have not been in the Dome Theater before, it is what it sounds to be, a dome. It's half a ball that is above your heads, and then you can really see the night sky as you would see it standing under the sky. It's an amazing thing, and I'm looking forward to bringing it back to live events, and hopefully you all can join us then. We're a little bit over time, so I don't want to keep you much longer, but I want to make one quick plea for the Fleet Science Center, just because we have been closed for 3 months. It's a little bit of a hardship for a nonprofit organization, because despite popular belief, nonprofit organizations do not get a lot of support from city, state, or federal. We do get some, and we appreciate all the support that we get, especially from the city of San Diego. They've been wonderful. But we're not entirely funded by government support. So we rely mostly or a lot on our attendance or revenue through ticket sales, the cafe, and our gift shop. And when you're closed for 3 months, then that is very hard for a nonprofit. So if you have some to spare and you enjoyed this program, please consider supporting us so we can keep these programs going. And with that, Lisa, thank you so much for another wonderful talk. And look,
Thank you.
Got my nerd shirt on for you.
I almost wore a Star Wars shirt, almost, but I decided to go Mars dust.
Yes, you should, and I will definitely buy that. Thank you all for joining us tonight. We really appreciate it. Stay safe, stay healthy, and we will see you back next month. Thank you, everybody. Bye.